In today's lesson, we're going to be looking at all the parts of the hypothesis test. Prior to now, we looked at what came before and what came after the calculations. Today, we're going to put those together with the actual calculations. So first, let's do a quick little recap on those pieces that we did and what comes sandwiched in the middle of them. So we looked at identifying a claim and putting in symbolic form for our first step. Once we have that symbolic form, we say, is that the null or the alternate hypothesis, and figure out what is the opposite. We need to decide on or identify our alpha, often that is provided in the questions. Determine our test statistic, critical values, and critical regions. So this is our actual calculations that we're going to be looking at today. Once we have that, we have our decision step where we either reject or do not reject the null hypothesis based on those calculations in step 4. And then step 6 is write that very clear statement addressing the original claim. So we're going to jump down now to those possible calculations. So those calculations depend on which kind of claim that we're testing. So we might be testing a claim about the mean, in which case we're using one of these two test statistics, or we could be testing a claim about a proportion, in which case we're looking at this test statistic. So the two test statistics we might be looking at for the mean are either Z or T, and what determines which one it is which standard deviation we know. So if we know the population standard deviation or a reasonable estimate of it, we can use Z. But if we know the sample standard deviation, we have to use T. Whichever one of those we use for the test statistic, we need to use the corresponding table and our significance level to find our critical value. So if we have a Z score for our test statistic, we have a Z score for our critical value, and likewise with the T. When we're testing a claim about a proportion, we do have to have those large enough samples that we can apply the sampling distribution we talked about earlier in the previous chapter. So remember, that means we need to have at least 5 successes and 5 failures, right? 5 in each category. Quick note on our notation here, in both, well, all 3 formulas, we have some symbols that are population and some symbols that are sample. So X bar is our sample mean, mu is our population mean that comes from the claim. P hat is our sample proportion, P is our population proportion that comes from the claim. So be careful with each of those things. So we're going to move on and look at our first example that we're going to work all the way through. So when you're looking at these questions, again, look for those key words. And when you're looking for the claim, if you do have some part of the question that actually ends in a question mark, find the wording of the claim in that question. So here we've got the average price is higher, specifically higher than $1.157 per liter. So that is going to be our claim. So higher is greater than. Then we want our opposite, our null hypothesis, is going to be less than or equal to, but remember, both your text and, sorry, that shouldn't have been there. Both your text and intro math do the second option where they say equals, because our formula is based on that equality, even if our diagram is based on the greater than sign. So the greater than sign does tell us our diagram is going to be right-tailed. Next step after we figured out our claim and our null and alternate hypotheses is to identify our significance level. Well, pretty clearly stated in this particular one, 1% significance level. While we're figuring that out, we might as well figure out our other values. So the 1.157 is going to be our population mean. The other average that we're given is going to be our sample average, which comes from that sample size of 150. Also, our standard deviation pretty clearly stated here, even with the symbol. So population standard deviation. So we know we can use the Z score. So we plug those values in, and feel free to pause the video a moment and do the calculation yourself. And once we've done that calculation, we can see that the test statistic works out to 4.32. But remember, that test statistic tells us nothing on our own. What we have to figure out, besides the test statistic, is our critical value. So that's based on our shaded region, which we said is right-tailed, and on our significance level, which we said was 0.01. So when we look it up on our table, if this part is 0.01, the other side is 0.99. So quickly looking at that formula sheet, I realize it might be a little small here. Let's see if I can enlarge it a bit so we can see better. So we're looking for the 99, so this is our closest one to 99. Let's see if I can get both the axes on the screen. There we go. So 2.33 is going to be our corresponding critical value. So when we go back to our sheet here, right, that's where the 2.33 on our label, that's the cutting off point for our shaded region. So we can see 4.32 is well past that shaded region. And if our test statistic is inside our critical region, remember that's the do's go together. If it is in there, it is rejecting the null hypothesis. Now be careful, we're not rejecting the claim in this case because our claim was the alternate hypothesis. So what we're rejecting, right, is the null hypothesis. So we're going to reject that. Our claim, on the other hand, is the opposite to that null hypothesis. So we're going to support the claim. So we reject H0 and support the claim. From there, we can write a statement. There is enough evidence to support the claim that the mean price is higher than $1.157 per liter in Calgary. Now, when you're writing that statement, the first few times you do some of these questions, you may want to use that flowchart you were provided. It could help you figure out exactly the wording of that claim. Again, you should be able to eventually get to, you can follow the logic and do it without the flowchart. Looking at our second example. So again, read through it, search for that part that ends in a question mark and see if you can find a claim in somewhere that question. So here we've got a significantly higher proportion have health and productivity plans. Okay, so is this statement about a mean, about a proportion? Because those are the only types of hypothesis tests we've looked at so far. Well, if we look in their question, I don't see anything talking about any sorts of averages or means, but I do see something talking about percentages. We also have a certain number out of a different total, right? So that fraction. So percentages and fractions are telling us we're looking at proportion. So specifically, this higher proportion is referring back to that 67%. So our claim is that the proportion is greater than 0.67. Again, no equals in the word higher or greater, so we're looking at each one. So our alternate hypothesis, less than or equals to, or if you rather, just the equals to. So our other pieces of information, our significance level, 10% this time. And I see I have a typo on this one, so I'll have to fix that because I typed in 1%. So let's make that a 10. There we go. And that 297 out of 415, as we mentioned earlier, is going to give us our value for our sample proportion. It's okay to leave it as a fraction. If you do change it to a decimal, try and keep all those digits in the memory button using your calculator. So we can plug that into our z-score for proportions. And again, feel free to pause a moment to get that value, which works out to 1.98. Once we have that value, we need the critical value to compare it to. Also note, both these questions, I did the test statistic first and then the critical value, but you could do the critical value first and then the test statistic. They both get you to the same point. So our critical value, we said that 10% there. So this time we're looking for as close to 90 as we can get. So that's going to be our closest value. Oh, I'm a little off the screen here. No wonder I'm having trouble finding it. So there's our one that's as close as we can get to 90. So 1.28 for our critical value. So when we compare where those go on our chart, right, the 1.28 is our gray region. Let's see if I can add in the text box. Put in those values. Oh man. So our 1.98 for our critical value. Let's make sure we can see that on our box. So test statistic. It's going to be way into that shaded region. Well, at least a little bit into that shaded region. And our critical value is going to be 1.28, right? So the test statistic is further to the right, so it's in the shaded region compared to our critical value. So then we're going to choose reject the null hypothesis. So there is enough evidence to support the claim, because again, we're rejecting H0. That means we're supporting H1, and our claim was H1. So there is enough evidence to support the claim that a significantly higher proportion have health and productivity plans. I'm going to skip over example 6 and say try that one on your own. So just quickly, I'll show the results so that you can compare them to your own. And we're going to move on to example 7 because it's a little bit different. So a drilling rig manager claims his technologists work a total of 500 hours, and this one, again, look at that. In this case, there's no question mark, but it's the statement telling us what to do. Test the manager's claim that the mean time worked is 500 hours. So there's where we're getting our claim from. Is going to tell us equality. So equality is our null hypothesis. So this is the first one that we've had, that our claim is the null hypothesis. The alternate hypothesis does not equal. So we've got a two-tailed test in this case. Now, part of what made this question different is that we are looking again at a means test, but this time we're not given the population standard deviation. We're given the sample standard deviation. Right, so we've got the 48.5 hours and the standard deviation is 12 hours. So if we're looking at a sample standard deviation, and I'm going to admit this question is a little bit, could have been worded better to make that clear that that was the sample standard deviation. I apologize for that. I do try and make them as clear as possible. So for this one, we have a 5% significance level. And because we're looking at sample standard deviation, when we plug those values in, we're going to be using T, not Z. So our sample mean, 498.5. Our sample size, got 30 weeks of this data. So we're going to plug those values into our T test statistic. So since we've got a T test statistic, we're also going to have to look at our T table for our critical values. So going back to those tables again, we're going to scroll down till we get to our T table. So remember, with the T table, you've got to be careful now, because in our confidence intervals, we were always looking at those two-tailed tests. Now, sometimes we are, sometimes we aren't. So for this particular question, it did happen to be two tails, and it was 95% confident. The other piece of information we need is our degrees of freedom. So just double checking over here, our sample size was 30. So our degrees of freedom, remember, on these kind of tests is one less than our sample size. So we want to find 29 in our table. So there it is. Our 95% was that third column, so 2.045 for test statistic. But because it is two-tailed, we have to say plus and minus 2.045. If it's left-tailed, make sure you put a minus on it. If it's right-tailed, it's just the positive one. So when we look at those values, right, we have plus 2.45, minus 2.45. If we compare where that test statistic falls at minus 0.685, well, it's going to be somewhere in the white region on the left side. So that is not in the rejection region. So we do not reject the null hypothesis. This time around, our claim is the null hypothesis, so that's also saying we do not reject the claim. Remember, these not reject ones are where we have those weaker statements. So that weaker statement is going to say there is not enough evidence to reject the claim that the mean time worked is 500 hours. So we're going to pause here. In this video, we will look at the p-value method of variation on this in the next video.